morning, everyone.
Morning, sir.
Hello, am I audible to you?
Yes, sir.
Yes, sir.
Okay, thank you. Uh, Today I'm going to start the practical very quickly because I'm at a hospital. So from there I'm taking your lecture. So today we are going to discuss about the synthesis of quinoline from aniline by scrub synthesis. This synthesis is well-known synthesis for preparation of quinoline derivative. And as you know, quinoline is a very important derivative which we can use for the as a drug for many diseases. Like it act as an anti-malarial agent, it act as an anti-cancer agent, it act as a anti-TB agent. So there are various types of activities of this quinoline derivative. This quinoline derivatives is also important for preparation of various heterocyclic dyes. And as you know, the application of dyes we can use for the coloring of the material or substrate. Here we are going to discuss about the basic skeleton of quinoline derivative. There are various substituents also we can carry out here. That's why it is mentioned R, means various groups we can introduce, or from the beginning means from the starting material. If you are having various kind of substituent, then also we can say we are having various types of substituted quinoline derivatives, and each and every quinoline derivatives are having their its own importance. But here, as per the requirement, as per the basic concept, we are going to discuss about the synthesis of quinoline by scrub synthesis. As I said, various methods are available, but today we will discuss about name reaction, which is associated with the quinoline derivative or quinoline synthesis. For that, what we require? We require aniline. Then second compound is glycerol. So aniline and glycerol, they react with each other in presence of sulfuric acid. Here sulfuric acid act as a catalyst, and here nitrobenzene as a solvent, because in this reaction we require high temperature, and that's why we require solvent which is having high boiling point. So that's why we have used nitrobenzene as a solvent. Due to this reaction, we will get this derivative. Its name is quinoline. As I said, if you are having various substituent on aniline, then we will get different types of substituted quinoline derivatives. Other methods are also available in the market. Now, in the as per the synthesis, what we require or how the reaction will start. Actually, aniline is known as base and glycerol is known as alcohol, which is known as neutral. So there is no reaction between aniline and glycerol directly. But if we use some catalyst, some initiator by which the reaction can be initiated, and if reaction can be initiated by certain catalyst or chemical that we can known as catalyst, here we require sulfuric acid. How sulfuric acid initiate the reaction, and on which compound the sulfuric acid will first act. Sulfuric acid first react with glycerol. From the glycerol, first of all, it will attack on this center OH, okay, on this OH, where the cursor is moving. And then after, first of all, the protonation will take place. When protonation will take place, it will convert it into OH2 plus. When protonation is take place, now oxygen having positive charge, that's why oxygen will pull electron from the carbon, and as a result carbon is giving electron, and that's why we will get carbocation. Now from this further deprotonation will take place and dehydroxylation is also take place, means from here OH and H is replaced, and as a result we will get CH double bond CH2 double bond CH double bond O. This compound is formed. Its name is acrolein. So first of all, or in this reaction, we can say first of all, glycerol will converted into acrolein by sulfuric acid. After that, this acrolein will act on or react with aniline. So in the next step, here you can see acrolein. Acrolein in presence of acidic condition, further protonation will take place on this oxygen and it will convert it into C plus OH. Means here we are having the positive charge, means the carbocation will form. After that, what happened? Aniline. Aniline which having lone pair of electron means nitrogen of aniline having lone pair of electron with which act as a nucleophile. This electron means double bond electron will migrate on this carbon and as a result at the terminal position we will get the positive charge. So carbocation will form. Now once we are having carbocation over here, the condensation reaction will take place or aniline react with acrolein derivative and we will get NH2 plus CH2 CH double bond CHOH. Now from this compound further migration or proton transfer will take place. Proton transfer will take place from here because it is NH2 plus. So H plus will be eliminated and that H plus will bind with the oxygen. When it bind with the oxygen, here oxygen having double bond, so oxygen will pull electron from the carbon. And as a result, this carbon become positive and oxygen become negative and the proton from NH2 plus will migrate over here. So now what we are having NH2, CH2, CH2, CH plus OH. Sorry, CH2 CH plus OH. Now carbon having positive charge and aromatic ring having pi electron cloud. When aromatic ring having pi electron cloud, it means electron density is high, so which act as a nucleophile and it will attack on this carbon and as a result cyclization will take place. When cyclization is take place at that time, this carbon is giving electron and that's why the positive charge on that carbon. After that, by deprotonation means from here removal of H plus will take place and again double bond will form. So here now again three bonds in the ring. Then after the reaction is highly acidic. So what happened? This OH will react with proton and as a result it will convert it into OH2 plus. When it converted into OH2 plus, removal of water molecule will take place from here and as a result when water is removed from here, this carbon become positive and then after deprotonation uh, will take place from here and finally we will get double bond over here. Then after in this reaction one more chemical is required. Its name is here iodine act as a oxidizing agent. When we call it a oxidizing agent, here oxygen is not added but removal of hydrogen will take place and two hydrogen from this position that is called NH and CH2. Removal of hydrogen will take place by and finally we will get the quinoline. Now how I2 will abstract or react with the hydrogen. Here nitrogen having lone pair of electron, so nitrogen giving electron to the carbon. When it is giving electron to the carbon from here, this hydrogen will be eliminated as a H minus and this hydrogen will be eliminated as a H plus. So from I2 also, one I become I plus, another I become I minus and as a result, two HI will form. Okay, again I am repeating from here nitrogen is giving electron to the carbon. So as a result, hydrogen will be eliminated as a H minus and this hydrogen eliminated as a H plus. One hydrogen is H minus, another hydrogen is H plus. Same way from the I2 also, one I is I plus, another I is I minus. So I plus will react with H minus and I minus will react with H plus and as a result the oxidation will take place and we will get the quinoline derivative. Here, role of this nitrobenzene is only to maintain the temperature of the reaction. Initially, when we mix sulfuric acid, glycerol, and our compound that is aniline, the exothermic reaction will take place. Slowly, the temperature increase up to 100 degrees centigrade. Then we have to heat it in a direct or sorry on sand bath and increase the temperature up to 140 degrees centigrade, and after that we have to increase temperature up to 170 degrees centigrade for 30 minutes. After that we will carry out the TLC, and if on TLC if your reaction is positive means the reaction is completed, then we can go for the isolation. Now normally in the isolation method what we do, in the normal condition generally we pour the reaction mixture in a water bath and we will get the solid and we can separate out. Here also we can do, but here excess amount of uh, nitrobenzene is there, that is C6 H5NO2 which act as a solvent. Then quinoline is semi-solid type of compound, and in this reaction aniline is also there, means some amount of unreacted aniline is also there. So as per the standard procedure we have to go for the steam distillation, but in lab instead of going for steam distillation we can do another carry out another reaction that is called salt formation reaction. In the salt formation reaction what we require, we require ZnCl2, we require HCl. So when we are having the product that is called reaction mixture, in that we have to add HCl and Zn. When we add HCl and ZnCl2, they react with each other and form a zinc salt, which is water insoluble or also insoluble in an organic solvent. So what we have to do, we have to add ZnCl2 and HCl. Okay. Before that, if we want to neutralize the reaction condition, then we can neutralize by NaOH. Once we neutralize, then first of all, we have to neutralize by NaOH and NaOH. Then after add ZnCl2 and HCl. Heat it. We will get the solid product that is called salt of or complex of zinc will form, and that complex we have to filter out, collect your solid, and then again add NaOH. When we add NaOH, the quinoline will be separate out and zinc salt will converted into ZnOH twice, which is water soluble. So by this way we can synthesize the product. Other methods are also available, that is known as extraction method. So by extraction also, that is called solvent extraction method, we can separate out or we can purify this compound. So we can say that there are different types of methods are available, but the most easiest method is the zinc salt or zinc complex formation method, and then after we can separate out the product. So here I have mentioned various types of methods, but I have explained the easiest method which is applicable or we can carry out the method or used at our lab. That method I have explained. So various types of methods are there. Here also some other methods are available, but I am not going to discuss all methods of purification. Okay. Now our aim is, means after completion of the reaction, we can interpret our compound by IR spectroscopy and NMR spectroscopy. Now, as per structures, first of all, again, we are going to the first slide. In the first slide, what we are having, starting material is aniline, product is quinine. One basic reaction is there. We can confirm the compound by chemical analysis or chemical treatment. How we can confirm? As you can see, aniline is known as a primary amine. Okay, so primary amine is there. It means it is easily soluble in 50% HCl. This is the common and simplest test. You can do it. Then this amine is tertiary in nature. So as we know, tertiary amines are difficultly soluble in 50% HCl. This is one test. Second test, if you are having primary amine, then we can go for the diazotization. If you are getting positive diazotization test, it means in your product aniline is present. If there is no red orange precipitate or dye formation is take place, which indicate you don't have the primary amine. It is only tertiary amine, and that is quinoline. But is it quinoline? That only we can confirm it by IR and NMR spectroscopy. Now, what we have to see in NMR spectroscopy and what we have to check in IR spectroscopy. So here you can see in NMR spectroscopy, NH2 means one signal, and 1, 2, 3, 4, and 5. Five different kinds of hydrogens are there. Out of five hydrogen, this AA means these are similar, BB are similar, and this one is C. Total five hydrogens are there, but AA, BB, and C means three signals for aromatic proton and one signal for amine, that is primary, that is NH2. So we will get a total four signal for aniline. Now if we go for the quinoline, now in quinoline, how many types of proton? So this uh, proton is ortho to the nitrogen, this is meta to the nitrogen, and this is para to the nitrogen. So all protons are having different environment, and that's why they are different in nature. Second thing, here this proton is attached with the aromatic ring. This proton is also attached with the aromatic ring. But if you are going for high resolution spectra, high resolution NMR, then only you can differentiate. Otherwise, these two protons are similar. And these two protons are also similar. But in high resolution NMR spectra, we can get the splitting, or we can get the differentiation. The reason is here nitrogen is present and which will affect on this proton. Okay, and here carbon is there which will affect on this proton. So that's why these two protons are again different. So if you are having HR NMR, that is called high resolution NMR spectroscopy, or FTNMR, then only you will get differentiate. Otherwise it may not be possible by the normal, that is called below 400 megahertz NMR spectroscopy. Here I am having the NMR spectra and IR spectra from spectral database. So as I said, what we have to check, we have to check NH2 first. So NH2 is there, then this is the pattern for NH2. Here you can see clearly pattern for NH2. Now, when we are comparing the IR spectra of quinoline and aniline, then sorry, we have to check whether this peak is present or not. If this peak is not present, it means the conversion of NH2 to other group is taken place. So let's see what happened. So here you can say this peak is absent. Okay, so we don't have any kind of absorption over here, where we are having absorption over here. And that's why we can say our compound is converted from aniline to quinoline. But further confirmation is required, and for further confirmation we can go for the NMR spectroscopy. Now in NMR spectroscopy, this is the NMR spectra of aniline and this is the NMR spectra of quinoline. As I said, this is NH2 and it having its own characteristic peak. Okay, it's a characteristic peak at this 3 to between 3 to 4. Then these two hydrogens are similar, as I said. So they are having same frequency. These two hydrogens are same, and this one is the different. So we are having total four signal for our compound, that is called aniline. Now for quinoline. For quinoline, as we can see here, the primary amine is absent. So there is no peak between 3 to 4. Here this peak is for NH2, but here we don't have any peak. So it is clearly we can visualize or we can see that amine that is called primary amine is absent. Now, as I said, how many signals we will get? We will get A, B, uh, 1, 2, 3 signals over here, and this 1, 2, 3, 4. So as per the resolution, as per the characteristic, we are having 1, 2, 3, 4, 5, 6, and 7 signals should be there. But as I said, it depends on which kind of NMR spectroscopy you are doing. If you are doing high resolution NMR spectroscopy, then only you will get the splitting. Otherwise, the merging of the peaks may observe. But what we have to check properly, we have to check that NH2 group over here and here NH2 group is absent, which clearly indicate that your compound is now converted from aniline to quinoline. Okay, then one more spectroscopy is there, that is called mass spectroscopy, and mass in the mass, based on the mass spectroscopy also we can find out the mass spectra or mass of the compound, and that is called final conclusion of the compound we can carry out, or we can say based on chemical analysis, based on the spectral analysis, we have confirmed our structure. So this is about the synthesis of quinoline from aniline. I have talked about this process ZnCl2. વાળી જે પ્રોસેસ તમને ડિસ્કસ કરી છે આ છે. As I said, several methods are available, but we are not going to discuss about all the methods. But for your reference, I have mentioned all the methods. Okay, so you can go through it. If you have any doubt, then you can ask any question. કોઈ question કોઈ query છે તો પૂછી શકે. હાલમાં છે કોઈને question કે કોઈ query? Okay, if you don't have any question or query, uh, then I will conclude the session. But I'm requesting you everyone, tomorrow I have shifted your lecture from 2 o'clock to 5 o'clock. So I will conduct your lecture as per the reschedule. Okay, so please join the class at not at 2 o'clock, but join the class at 5 o'clock. So thank you one and all. I am leaving the meeting. Thanks.